one of the two computer science research labs at the University of Paris 7, and I'm also Debian developer since 2001. And I would like to present to you an ongoing research project called MANCOOSI, Managing the Complexity of the Open Source Infrastructure. This is a research project in the 7th research framework of the European Union. So what's this about? Well, first of all, we are looking at component-based software deployment and installation. And you all know that today's software systems are very complex, composed of components. And when you have components, you have many interacting components, you have dependencies between components. And these components are often independently developed, maintained, but must be deployed with one central infrastructure and must in the end, of course, run and must be installed in a coherent way on one single system. And with that, you have, of course, also the problem that components are changing. You have the life cycle of a component on a system, is you have installations, you have upgrades, and in the end, maybe you also have removals, and you have to maintain all this in a consistent way. So this is a general problem, of course, of computer science and of component-based systems, but it's in particular pressing, we think, in the context of free and open software, and this is why our project is in particular interested in free and open source software. Why? Well, what makes this problem particularly difficult in our context of FOSS software is that we don't have a central agent, a central architect who's controlling what's going on in this world. We have a very fast and distributed, of course, development. You all know the slogan: publish early, publish often. We have strong interdependencies of packages in this world for various reasons. We try to factorize code, not to duplicate source code between packages, which is on the one hand, of course, a good thing for various reasons, for instance, for security reasons. But on the other hand, it also increases the complexity of the dependencies that we have between components. We have a very large code base. In Debian we have now something like 21,000 packages. This is developing quite fast. I think 5 years or 4 years ago we had something like 12,000 or 13,000, and that's going on and on. I have no idea whether it's going to stop or whether it's going to stop at all. Okay, so we have to find tools and develop tools which could help us to maintain this fast evolving component-based and very dependent and very interdependent system, and this is exactly what we are going to do in this project. So one of the particular problems that we would like to have solved at the end of this project, at the end of these 2 years, is a situation like this. So this is something which did not happen to me, but one person in our project prepared to give me this slide. Apparently he was a little bit unlucky. So what we try to do here is, this was in the context of the Debian Dynamics distribution. He wanted to install so the DebHelper package, which is one of the packages which is used, which gives you tools to develop Debian packages. So he tried to install the package, and this is what the apt library, which is trying to solve the dependency relations between packages, gave to him. So it told him, so these packages are going to be installed, which is quite good, but also these packages will be removed. And when you look at the packages, so this is quite scary. So you see here, for instance, things like X-Window System 4. One of them might be just a task package, which is not so important at the end. But a user who will see this will, of course, be scared away by saying, well, wait. When I install this package, it will throw away all of the X-Window system and stuff like Xlib, 6G, and all these libraries. And of course, what he will do in the end, rightfully or wrongfully, will of course be just abort and stop this process.
No, everybody press yes.
You do?
In that conf. Yes.
Oh, I won't. So some people do it, and if you do it, you should understand exactly what the consequences are of what the system is proposing you. Okay, there are good reasons, of course. Good reasons in particular software distribution, for instance, like Debian, why this must happen at some points of time. In particular, when you are using an unstable distribution, which is just a staging ground for data distribution, which is going to produce in the end. But there are also cases where these dependencies could, in principle, be resolved, but are not resolved because of drawbacks of the actual solving algorithm. So our goal to summarize is this is what we have written in our project proposal to enable safe, efficient maintainability of the open source software infrastructure built out of software packages. And to do this, we have two streams of activity that we have proposed for our project. The first is to conceive and implement a transactional update process which would allow to make a rollback. So which means you start all the process of installing some packages, which will remove some packages, install some new packages, maybe install new configuration files, maybe change configuration files. In the end, you find out that this is not what you wanted to do, because this stopped your mail transport agent to work or something else, and you just want to backtrack to the situation of the system that you had before. So this is one of the activities, of the fields of activities where we would like to work on, and this is something we would like to have to work in the end. The second stream of activity is to design algorithms which would help us to get better algorithms to planify upgrades and better algorithms to solve the constraints which exist on the dependencies between the packages that are going to resolve, and which would, in the example of the slide you have seen before, for instance, give you a solution of an upgrade path if it exists. So these two streams of activities, these are structured into work packages. So work packages is what you have in a European project. There are some non-technical work packages like administration and discrimination, stuff like that, and I won't talk about this. But there are 4 technical work packages, and these work package 2 and 3 are on the first stream of transaction upgrades and rollbacks. So this consists of 2 parts. First of all, to build a formal model of what you have in the system. So this would concern building models of software artifacts that you want to install, or of persistent data, like for instance files or configuration files that you have on the system, and probably also dependencies on hardware or network availability. So in this part, modelization of what you have and what you want to do, and in this part, conceive and implement the actual tools which are going to perform transactional update processes which would allow a user to do a rollback, to do a backtrack of an upgrade process. We have several industrial partners in the project who are distribution editors and who will integrate this into their package installation tools. So this was the first stream. The second stream is now on a more abstract level, where we won't look on software artifacts and persistent data, like for instance files or hardware dependencies. Here we are looking just on the dependency relations between packages, and here we would like to provide better algorithms to compute upgrade paths from one package installation to another one. Here again we have two work packages which will work on this part. Work package 4 will in fact improve on the algorithms, on the actual solver algorithms which are used in order to solve dependency relations which can just be expressed by some graph, some binary graph of relations between packages using techniques like Z-solvers or constraint programming. And in work package 5, we will collect data which will of course be used as input for our research on the new algorithms, on the solver algorithms, but data which will also serve us in order to build a database of hard instances of problems of computing upgrade paths, which will be used in order to make a competition. So we will start a competition in conjunction with one of the international conferences in this field of planning and constraint solving. Conferences like, for instance, well, possible candidates might be, for instance, SAT or CP or other conferences on constraints, and we will start a competition where we will provide a set of example problems and actual implementations of these algorithms. Can participate, will issue a call for participation, and they can participate in this and compete in order to calculate good solutions. Talking about package dependencies, There also was, of course, the EDOS project, which was mentioned several times in earlier issues of this research room here, in this room even. So in this EDOS project we had a different focus on package dependencies. The difference is made, well, first of all in EDOS we also had other goals in the quality of open source distributions, but one of the issues in EDOS was package dependencies. And what we were looking at EDOS was more the global consistency of a FOSS distribution, and we were asking the question whether the root distribution that you would construct, you as a distribution editor, is coherent in itself, and whether it allows, for instance, every package to be installed in this distribution. And what we developed in this project, that was tools to be used by distribution editors, like for instance MANCOOSI or Debian or others. Now in MANCOOSI, in the new project, we are of course building on the experience that we have gained in the EDOS project. Some of the partners of the MANCOOSI project are also coming from EDOS, of course, but what we are doing here is we are more looking on the side of what we call the client side. That is what's going on the machine on which you want to install or to upgrade or to remove your packages. And what is going to come out of this project is tools which are going to be run on the system itself, on the system on which you would like to install or to upgrade your installation. The partners, so we have 10 partners in this project. 3 of the partners are industrial partners who are in fact distribution builders and distribution editors, Kaiser Machika and Matriva, who are building RPM-based distributions. PixArt from Argentina, who is building a Debian-based institution and selling in fact many machines in Argentina, which are coming with the Debian reinstalled. Then we have academic partners. So us, University Paris 7, University of Aquila in Italy, INIS-ID, this is a private research institute in Portugal, it's a research group working on constraints. University of Nice, Sophia and Police, ILOC, which is again an industrial partner, specialist on constraint solving technology, University Leuven, not far from here, and University Tel Aviv. Okay, last word, please bear with us. So we had our kick-off meeting, so in fact yesterday. The official starting date was 1st of February, but we came just right here from the kick-off meeting. Several of the people on this photo which was taken yesterday are sitting here in this room. So we are all ready to discuss with you, to answer to your questions. So please talk to us when you are interested. We have a web page, of course, MANCOOSI.org, which is operative right now. Of course, we don't have any results now. For the moment, you will find on the web page what I've told you right now. But of course, all our results will be open source. All our results will be published, and all our tools will be under an open source license and available to everyone on this web page. Okay, thanks for your attention.